Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we are going to solve majority element problem. The problem states that we are given an array of integers and our task is to find the element that appears more than n by 2 times. We may assume that the majority element always exists in the array. So, we will start with a brute force approach. We will understand why it is inefficient and then we will move to the optimal Boyer-Moore voting algorithm. So, initially the array size would be n and the majority element appears strictly more than n by 2 times and only one such element can exist. So the idea for brute force approach would be for every element we will count how many times it appears and if its count is greater than n by 2 then that's our answer. So let's initialize a variable n with the length of the given array nums and for int I0 I less than ni plus plus let's initialize a count as 0 and for j starts from 0 j less than n j plus plus. So if nums of j is equals to nums of I, that means we are simply checking if it is equal. If it is equal then we will increment the count and after coming out of this for loop we would check if the count is greater than n by 2. If yes, then we can return the number, return nums of I. Otherwise at the end we would return -1, which means that is not present, but it will never reach this because it is guaranteed that the majority element always exists in the array. Let's run the code. Okay, it is working. So since we have used nested loops, this is slow for larger arrays and we can do much better. So the optimized approach for this can be done by using Boyer-Moore's voting algorithm. Let me comment this. Okay, so the majority element appears more than all other elements combined. So we can cancel out different elements. Now, how this works is we will assume the first element as the candidate and we will maintain a count. If current element is equals to that candidate, then we will increment that count. Otherwise, we will decrement the count. When count becomes 0, then we will pick a new candidate. It would be easy if we write the code and then discuss. So let's say the candidate is initially the first element in the given array. And let's say the count initially is 1 because we have already considered the initial element. Now let's start from I1 and I less than nums dot length I plus plus and now if the current element nums of I is equals to the candidate, then we would increment the count. Otherwise we would decrement. Now if count is 0, then the candidate would be the current element and the count will be reset to 1. At the end we would return the candidate. Yes. So let's run the code. Okay, let's submit it. Okay, it is working. So the brute force approach helps us understand the problem, and Boyer-Moore is a key pattern here. No extra space, single pass. And the time complexity would be O of n because we have done it in a single for loop, and the space complexity would be O of 1 because we did not use any extra space. So let's dry run with an example. Maybe let's consider this. So initially, let's say the candidate is 2 and the count is 1. Now at 2, the candidate is 2 and the count is 2. And then when we go to 1, the count will be 1 because it is a different element other than our assumed candidate 2. Since it is 1, we would decrement the count. The condition is written here. If we encounter the candidate which is already assumed, then we would increment the count, otherwise we would decrement it. So initially the count here would be 1. Our assumed candidate is 2. Our count will be 1. Count will be 2. Count will be decremented to 1. Again count will be decremented to 1 because count will be decremented to 0, and the new candidate would be 1 because it enters into this and the candidate is the current element which is 1. Okay, then again the count will be 1. Count will be 0 here, count will be 1 here, and then when we go to 2, the count will be decremented to 0 again, and then the new candidate is 2 now. And after coming here, the count would be incremented to 1, and at the end the assumed candidate is 2, so the answer is 2. So yeah, that is it for today's problem, and I'll see you in the next one.